Alright, we are on page 65. And this is the Module 3 test review. We're going to do pages 65 and 66 over the next couple videos. And when you're done with those and when you complete all the lesson worksheets, you'll be ready to take the Module 3 test. Alright, number 1, or at the top of the page I should say. 5 friends divide 3 bags of apples equally between them. Write the division represented in this situation as a fraction. I want to remind you what we did at the beginning of this module, how we learned about this. So this is not the answer. This is just a review of what we did earlier. We had a blocks of clay problem where we had 3 blocks of clay, and those 3 blocks of clay were divided by 4 friends. Remember that? And then, so when we figured out how much clay each person got, they each got 3/4 of a block. So what we did was we drew the conclusion that when we set up a division problem, which this is, the dividend becomes the numerator and the divisor becomes the denominator. It's really that simple. Now this is the same thing here. The directions even tell you all that. It says write the division, it's a division problem, write the division as a fraction. Well, the division is, and this is where you got to be careful about it. Do we take 5 people and divide them by 3 bags of apples? Or do we take 3 bags of apples and divide them by 5 people? They gave you the information here backwards. This is 3 bags of apples divided by 5 friends. The people are always going to be the, what does the dividing? It's always going to be the divisor. So what we can do is we can do the same thing as before. 3 becomes the numerator. 5 becomes the denominator. And what we do is we just ask ourselves, what is 3/5? So it's 3/5 of a bag. 3/5 of a bag. If we wanted to be more clear, we'd say 3/5 of a bag of apples. That is the answer. Let's move on. I think I can just remove this whiteboard here and see the next set. Okay, it says write each rational number in the form of a over b, where a and b are integers. In other words, can we write this just as a plain fraction? And we can. In this case, it's going to be an improper fraction. So I'll remind you that we take 5 and 1/6, and we do 5 times 6, and we get 30. Plus 1 is 31. It's 31/6. And number 3, can we write negative 12 as a fraction? Yes, every whole number, every integer can be written as a fraction. It's itself over 1. All right, good. Let's move on to the next set. Oh, there we go. Yep. It says determine if each number is a whole number, integer, or rational number. Include all sets to which each number belongs. So what is negative 12? Most kids would look at this and say it's an integer. But since we can write it, we just proved it. Since we can write it as negative 12 over 1, that also proves it's a rational number. The only thing it's not is it's not a whole number. So for number 4, I'd say integer, integers, and rational numbers. And number 5, is 7 over 8, is that a whole number? Of course not. It's not an integer either, because by definition an integer is a whole number and its opposite. So it's got to be a whole number or it's got to be a negative whole number. It's neither of those. So the only thing, number 5 is 7/8, the only thing it is a rational number. So it belongs to the set of rational numbers. Okay, moving on, 3.2, identifying opposites and absolute value of rational numbers. Number 6 says graph negative 3, 1 3/4, negative 0.5, and 3 on the number line. The whole numbers are going to be really easy. Negative 3 is just right here. You can see it. 1 3/4. That's going to be between 1 and 2, but it's not going to be in the middle. That would be 1.5. So it's going to be over closer to 2. It's 3/4 of the way over. It's right about there. I'm going to label that one. I'm going to label all of them actually. Negative 3. So it's going to be 1 3/4. Okay, we've got negative 0.5. So negative 0 means go to the negative, but I only go halfway because 0.5 is a half. So it's halfway between 0 and negative 1. Negative 0.5. And my last one is positive 3. That's a super easy one. Okay, let's just check that I got those. Negative 3, yes. Negative 1 3/4, yes. Or positive 1 3/4, yes. Negative 0.5 and 3. Okay, good. All right, done with those. And number 7 says, find the opposite of 1/3 and of negative 7/12. Well, the opposite of 1/3, the rational number that's the same distance from 0 but on the opposite side of the number line is simply going to be negative 1/3. And the the rational number that's going to be the same distance from 0 but on the opposite side of the number line of negative 7/12 is going to be positive 7/12. All right, and number 8, find the absolute value of these two numbers. Absolute value means distance from 0. That's what absolute value means. How far away is this from 0? It's 9.8 spaces. The absolute value of all positive numbers is that number. How many spaces away from 0 is this? It is 10/3 spaces away from 0. It's not a negative because absolute values can never be negative because they're distances. So it's just 10/3. Okay, let's move down to the bottom of the page. .3, comparing and ordering rational numbers. Over the last week, the daily low temperatures in degrees Fahrenheit have been -4, 6 2/10, 18.5, -5 9/10, 21, -1/4, and +1 7/500. List these numbers in order from greatest to least. Now, this might seem a little overwhelming because there's so many numbers there. But since we're starting with the greatest, I want to point out to you that all the positives will come first and all the negatives will come last, which means I can just worry about the positives to start. So what I'm going to actually do here, and I can't, I'll have to undo this later, but what I can do here is I can smudge out my negatives because they can't be the greatest numbers. Now I've got 1, 2, 3, 4 positive numbers. Now, if you think to yourself, oh, I've got decimals, I've got fractions, this is going to be stressful, just pay attention to what the whole numbers are. We've got a 6, we've got an 18, we've got a 21, and we've got a 1. It doesn't matter that that 1 has a decimal next to it. It's still not going to be greater than 21 or 18. So using a lot of common sense, we can say that 21 is our greatest value because it's bigger than 18. And then 18 is going to be bigger than 6, so it goes second, 18.5. And then 6 2/10 goes third, and 1 7/500 goes fourth. Now, I got all those not by being really good at converting between fractions and decimals. I got those just by identifying the whole numbers. 21 is bigger than 18, that's bigger than 2, it's bigger than 1. Now what I need to do is bring my negatives back because I got to use those now. And I can smudge out my positives. And I do want to get rid of my positives because I don't want to accidentally reuse those. I'm going to change color here. I've got -4, -5.9, and -1/4. Remember, I'm going to the least. So the least would be farthest to the left on the number line. And farthest to the left on the number line would be the greatest negative. So I want to find the closest to 0. And then if I'm moving, just think about it this way. I always try and draw this image for you. Think about it this way. This is 0, and the farther we go this way, the less it gets. I know the numbers get bigger because we go -8, -9, -10. The numbers get bigger, but the value, because they're negative, gets less. So I want to get the one closest to 0. That's going to be the next number I list. And then as I count to the left, I list them as I'm moving to the left. So what would be closest to 0? It's going to be -1/4. That's practically right at 0. I mean, on a number line, it's like almost touching 0. So that's next. And now I've got -4 or -5.9. I would come to -1, -2, -3, -4. That would be right here. -5, and then -5.9 is almost a -6. So -4 would come next. And -5 9/10 would come last. All right, one more question. How can you order rational numbers from least to greatest? My favorite way to do this is to plot them on a number line. And then list them, or I guess it would be read them. I don't know if it's list them or read them. and then read. I spelled read wrong. From left to right. Now, if you think to yourself, well, Mr. Smith, you just did that on number 9, but you read them from right to left, I would say I agree. On number 9, we were listing greatest to least. So if you think about a number line, the greatest would be the positives, and the least would be the negatives. So if it says greatest to least, you start over here, and you list them that way. And if it says least to greatest, you start over here, and you list them that way. All right, good job. You are done with page 65.